Thanks for joining us. My name is Matt Poirier. I'm Director of Policy here at the Building Decarbonization Alliance. Um, and excited to welcome you to today's discussion on the impacts of refrigerants in an electrified heating and cooling world. This is part of a Building Decarbonization webinar series that we've launched, aimed at provoking discussion and sharing knowledge from leading experts in the energy transition. So we'll be holding different webinars on different topics every other month or so. So stay tuned on your socials and in our newsletters for any upcoming events. For the francophones among us, malgré que le webinaire soit présenté en anglais aujourd'hui, vous pouvez activer l'option afficher les sous-titres située en bas de votre écran et recevoir une transcription simultanée si vous désirez. For those who are attending, please do let us know where you're joining us from today by adding your location in the chat box just at the bottom of your screen. We at the Building Decarbonization Alliance have staff across many different provinces, so we acknowledge the many traditional territories of the Indigenous peoples on which we work and live. We recognize and respect the ongoing relationships that Indigenous peoples have to the land, and we commit to the ongoing process of reconciliation. Many of you are probably familiar with our work, but for those who are new to us, just want to give a quick intro on the Building Decarbonization Alliance. We're a nonpartisan and cross-sector coalition working to change the narrative on building heat, inspire and inform industry and government leadership, and accelerate market transformation. So we see electrification as a credible, compelling, and capable pathway for decarbonization. It's not necessarily the only means, but it's going to be a key means for this sector. So we're working on accelerating that. And it's important to note that we're not doing that alone. We've got over 180 industry partners spanning the building ecosystem, as you can see here. So, and many more are joining every week. We're an initiative of the Transition Accelerator, which is a Canadian nonprofit working to solve complex challenges, like how to build a prosperous future through pathways that lead to net zero emissions. The Transition Accelerator has a few different initiatives, Electrifying Canada, the Hydrogen Hub, and ourselves, and works across a few different focus areas as well. The approach at the Transition Accelerator helps inform our whole of economy approach by keeping our eye to a net zero future economy. So it's how do all the pieces of the puzzle fit together to get us to net zero by 2050. For today's session, I'll do a quick, I've got, I think, 2 more slides on some of the initiatives that we're undertaking for the year. Then I'll introduce our moderator, Roberto, who's going to invite our panelists to share their experiences and perspective on the issue of refrigerants. We'll save some time for questions during the session, so please don't hesitate to write your questions in the question and answer section at the bottom of your screens. And if you'd like to address it to a specific panelist, please just note it in the question itself. So while we're working on a number of different issues, including the case for building electrification and our pace of progress report and developing a new national building decarbonization open source model, today's session is going to be focused on refrigerants and the important connections to greenhouse gas emissions. Lastly, I wanted to just note that if you do like today's discussion, you should join us for the National Building Decarbonization Forum. It's going to be happening in Ottawa, April 17th and 18th, and it's going to bring together industry leaders, construction professionals, civil society, government officials, Indigenous leaders, and others to really focus on the pathway to electrification. So we'll explore the most promising pathway to achieve net zero. There'll be engagement, information exchange, and in-depth discussions to unpack some of the challenges and opportunities and identify some of the immediate actions needed to accelerate the transition to net zero buildings. So now to our moderator and panel. Roberto has been active in the building industry for more than 2 decades. In 2020, he joined Zebex, where he serves as a director of programs. He began his career earning a mechanical engineering degree and since worked on both new developments and in the existing buildings, helping with project management, general contracting, property management, and diving into the nitty-gritty of building sciences. Most importantly, he's got a deep-rooted belief that the building industry can make a major contribution to address the climate crisis. We're really thrilled to have Roberto here today to help moderate this session. So over to you, Roberto, to introduce the panel.
Thank you, Mathieu. So just, a little bit of 30 seconds of background. ZEBEX was created in 2018, and in 2021, we actually created the Building to Electrification Coalition with the support of BC Hydro and the City of Vancouver. That's why I've noted that I'm here representing B2E, the Building to Electrification Coalition. Both are now B2E, ZEBEX are two of four building decarbonization programs of the Zero Emissions Innovation Center now. So with that, maybe I'll turn it over to Heather. Why don't you start by introducing yourself?
Hi, I'm Heather McDermott. I'm a senior advisor and principal at McDermott Climate Consulting, which specializes in decarbonization solutions for single-family homes in Canada. Martin Looms.
Good morning, I'm Martin Limas. I am the Vice President of Government and Stakeholder Relations for HRAI, and HRAI is the Heating, Refrigeration, Air Conditioning Institute of Canada. It's a mouthful. We are the industry association representing the HVACR sector, comprised of manufacturers. We have about 100 manufacturer members, including refrigerant manufacturers, but also product, i.e. heat pump and furnace manufacturers, and wholesalers, distributors, and contractors, about 1,200 members across the country. I'm just going to say, for what it's worth here at this time, I'm not a subject matter expert on this issue, but we have lots and lots of subject matter experts within our industry who are pretty active on the file. So my job is to engage with government and regulators, and that's a little bit of what I'll be talking about later. Glad to join. Who am I handing off to? Mark?
Yeah, I'll go ahead. Hi, I'm Mark Jerome. I work with Clear Result. We're a energy efficiency implementer based in Austin, Texas. We also have multiple locations across the U.S. and in Canada. I'm a senior technical energy manager. I work in the engineering department and lead a team of engineers that work on different program implementation pieces for utility partners. And my experience goes came up through the trades. Been doing HVAC work for nearly 30 years before I got into the consulting world about a dozen years ago, and have a EPA 608 refrigerant handlers card, having a trainer and a proctor for EPA 608 as well, which is the regulatory body for refrigerant handling in the U.S. With that, I'll pass it off to Sophie.
Hi, I'm Sophie Gagan. I'm a climate campaigner at the Environmental Investigation Agency, which is a European NGO working on reducing emissions of fluorinated refrigerant gases and advocating for sustainable cooling and heating. I've been with EIA for about 6 years, and I work very closely on the EU and UK F-gas regulations, as well as at the Montreal Protocol, and with various industry and other NGO stakeholders in and around Europe on cooling and heating. Thank you very much.
Excellent. So maybe to kick off this panel discussion, I'll start with some seed questions here, and I'd like to see some questions dropped into the chat from the 89 participants that are here right now. But I think these seed questions will probably help with triggering some ideas of what to ask. So Heather, maybe we'll start with you. What in your view are the most pressing R&D needs in the HVAC industry that will accelerate the adoption of low GWP refrigerants, and improve system efficiency as well?
Actually, Roberto, before I dive into that, perhaps I should just give a little bit of context. So I've prepared a couple of slides just giving some background context information for people. And I'd like to sort of start out by saying that, heat pumps really are the future for heating and cooling buildings around the world, but especially here in Canada. And that's because they are the most energy efficient way to heat and cool buildings. And when you have low carbon electricity, as we do have here in Canada, they're also very low emissions. And what's more, they're often the most cost-effective way to do heating and cooling of our buildings. There have been several studies across Canada that have looked at the economics of heat pumps, and in many provinces, heat pumps win out over gas furnaces and alternatives. And we installed a heat pump in our home 3.5 years ago, and one of the things that really surprised me was that heat pumps seriously increased the comfort of our home. Because heat pumps provide more even heat, most occupants will often find that they're more comfortable after a heat pump has been installed. And as we're seeing more and more extreme heat days and summers across Canada, adding air conditioning to buildings and homes is becoming not just a luxury, it's becoming necessary for climate resilience. So heat pumps really are the future, but they do have a weakness, and that's the refrigerants that are used to move the heat in and out of buildings. And they are, those refrigerants happen to act as greenhouse gases when they leak. The good news is when heat pumps are properly installed by qualified installers, they will rarely leak. And our analysis shows that in Canada, it takes on average about 3 years of operation to offset the average lifetime leaks from heat pumps. So installing heat pumps is still the best climate solution. But it's more and more people are aware of this refrigerant problem, in part because of Project Drawdown, which is an international organization that researches and profiles science-based solutions for the climate crisis. And they rank refrigerant management among the top 10 ways to reduce greenhouse gas emissions. So if we can just go to the next slide. Right now in Canada, the vast majority of heat pumps, especially in the residential sector, are using R410A refrigerant. And the good news is it has an ozone depletion potential of 0, thanks to the Montreal Protocol. And they are class 1 refrigerants, which means they're low toxicity and low flammability, but they have a global warming potential of over 2,000. That means that they are over 2,000 times more potent at trapping heat in our atmosphere than carbon dioxide. Canada has signed on to the Kigali Amendment to the Montreal Protocol, which calls for the phase down of high global warming potential refrigerants. Here in 2024, we are to use 40%, we are to use and produce 40% less of these refrigerants. And in the shorter term, the refrigerants that are most likely to emerge are R32 and R454B. They're also 0 for ozone depleting potential. They have far lower global warming potentials, but they're not A1. These are A2L. They have low flammability. In the longer term, one of the refrigerants that gets talked about a lot is R290, also known as propane. It has a global warming potential of 3, so that is fantastic, but it is flammable, so it has class A3 designation. And I'll just go through those class designations on the next slide. Next slide, please. Thank you. So refrigerants are classified by their toxicity and their flammability. If they have an A, that means they are lower toxicity. If they are B, that means higher toxicity. And then they're also rated for flammability from 1 to 3, 1 being no, not flammable, and 3 being high flammable. A1 refrigerants are the ideal, and R410A is an A1 refrigerant. But it's hard to find refrigerants that have all the properties that we want. And so we are looking at A2L refrigerants. So those are very low flammability. They're hard to ignite and slow burning, but they do burn. And of course, propane is an A3 refrigerant. So we are having to look beyond A1. It's actually pretty difficult to find refrigerants that meet all the characteristics that we're looking for. They, of course, have to be low ozone depleting potential, low global warming potential, low toxicity, low flammability, but they also have to be affordable. They have to work, they have to move heat in the temperature ranges that we're working at. They have to use pressures that are pressures that we can build into our heat pump systems. There are a lot of targets that we have to meet, and that's why it can be so challenging to find alternatives, and why this transition is maybe more difficult than we'd like. So I'll pass it on to, I think it's Martin is going to speak next.
Sure. I'm going to say just a couple of things to lead in, kind of playing off of what Heather raised. I'll say first on the refrigerants, you know, there is no perfect refrigerant, as Heather alluded to. Doesn't mean the industry isn't working hard to develop one. But in light of the transition that's in front of us, the regulatory transition that the industry is going to be compelled to comply with, we have certain gases that we can work with that meet certain of the requirements. But rest assured that the chemical industry is working hard to develop the perfect refrigerant that is low toxicity, low flammability, low GWP, low ozone depleting. They haven't come up with that magic bullet just yet. Some would say maybe it's CO2, but they have other issues with CO2. They have to operate at higher pressures, which creates different technical issues in application. So just that as a preliminary comment. And another quick comment is, this isn't the first phase down or refrigerant transition that our industry has gone through. It's one of a series, and we have quite successfully, it's worth noting, transitioned away from ozone depleting gases to the point where it's been a major environmental victory, largely contributed to by our industry, the HVACR industry, having taken responsibility for producing low ODP gases. Another just quick comment, and it'll feed into something I'll be sharing later about the biggest control on the problem that Heather described of leakage is technician training. It's technician competency, right? A properly installed heat pump or any refrigerant containing system, whether it's an air conditioning system, whether it's a rooftop unit or an ammonia system serving an ice rink, whatever the case may be, the competence of the installer and the service person is by far the greatest determinant of leakage or non-leakage. And that sounds great, except we have a serious problem in our industry, and that is we don't have anywhere close to the number of competent qualified technicians that will be needed with the growth of heat pumps as a common market choice. So we're going to need to work really aggressively to find to recruit and train people in the industry. So I'm just saying that as a preamble. As I said earlier, my main role at HRAI is to deal with regulations and government. And what we're looking for as an industry, the industry is prepared to go through the transition to lower GWP refrigerants. But what we need is clear regulatory guidelines and a minimizing hurdles. So a lot of our work at HRAI is to try to work with government to make the pathway as smooth as possible. So some of the hurdles that exist today that we're working on quite aggressively and have been for 3 or 4 years. One is the potential lack of alignment between Canada and the United States on the regulatory approach to the phase down. So some of you might know that Canada signed on to the Kigali Amendment fairly quickly upon its international. When it was put out there, Canada signed on relatively early. The United States did not under the previous administration. So Canada set its regulations under what's called the ODSH-ODSHAR, or Ozone Depleting Substances and Halocarbon Alternatives Regulation, ODSHAR. that specifies the products that can be sold and the GWP levels, et cetera, et cetera. That's our regulatory frame. The US more recently as October of last year, finally kind of caught up. And in fact, they didn't just catch up, they went a little bit further than what Canada has done in terms of setting limits. That has caused a little bit of grief among our manufacturers in that they want to see a harmonized, they want to see the North American market treated as a homogeneous entity to the extent possible. So we have to work a little bit with Environment and Climate Change Canada to make sure that the regulations, if possible, can be aligned with the US, and that's an active file that we're working on right now. Having said that, I don't think the way things are spelled out today will create any supply chain disruptions in the near term. They might be a cause of concern several years down the road, but they're not a problem today or in the next couple of years. Much more important is the guideline for practice for refrigeration mechanics who work in the field, who work with heat pumps, who work with these gases. And the work of refrigeration is defined by CSA B52. So initially our concern about that was it hadn't been adopted yet. There was still an ongoing discussion with the CSA committee that oversees it. And fortunately, they resolved all the little differences and came to consensus late in 2023, and it was adopted in December, which paves the way now for the real challenge, which is to have that code adopted at the provincial level. The CSA B52 code has no meaning until and unless it's adopted at the provincial level. So, and each province in Canada has the right to review the B52. And they all have, I'll just add this, they all have different processes for doing it. Most provinces will try to do it within 6 months. Some will take a couple of years. We've urged every province in the country to go through an adoption process that expedites or that gets through the review as quickly as possible, so that B52 is the law of the land in all parts of the country by the end of 2024. So that's ongoing work we're doing with every province in the country. I'm going to say it's looking pretty encouraging that will happen, and that will be a major hurdle overcome if we get that to happen. Okay, so let's just move to the next slide. So that doesn't mean all the hurdles are resolved. There are other regulatory challenges still. Two that I'll mention. One has to do with transportation of refrigerants in products or in tanks, transportation of dangerous goods. There's a whole lot of regulations that also have to be addressed to ensure proper shipping and handling and storage of these gases long term. Not an insurmountable hurdle by any stretch, but it is something that has to be done. And lastly, we also will need to see building code, which defines new construction, will need to be aligned to properly reference the new version of CSA B52. Again, every province has a different process for adopting building code, and I can say none of them will have the new version of building code in place before the end of 2024. In some provinces, it's not an issue because they just default to the most recent version of B52. In other provinces, like Ontario, they actually reference a specific version of B52, and the current reference in building code is to the now old, outdated version. So we're going to need to see government either sidestep building code or do a ministerial directive of some sort, or find some way to have B52 recognized in building code. Or we may have a problem in what types of products may be permitted to be installed in new homes. We don't want to block the way to having heat pumps installed in new homes because they're not permitted under the old referenced the older version of B52. So that's a remaining hurdle. We think we can get there, but there's still a lot of work to be done to smooth the way there. And the last point I want to make is back to the first point I made, which is the importance of trained technicians. I'm not sure if everyone on this call will know that the installation of heat pumps falls under a regulated trade across the country. It's the refrigeration trade. You can assume that most refrigeration mechanics more or less know what they need to know. Most of them have ODP training, and that talks about proper handling of refrigerants. You cannot vent refrigerants into the atmosphere. That's illegal. We have training. HRAI has training, and it's actually mandatory in almost every province that technicians take that training. We're now recommending that training be modified to include an understanding of handling of A2L refrigerants, mildly flammable refrigerants, as a new technical need. This is about training existing technicians. Last comment I'll make before passing the torch is, and this is a very serious, I said it already, we don't have enough refrigeration mechanics in the country to do the work. A report that was issued just a couple of weeks ago by BuildForce Canada says that if we are going to meet the climate targets that the federal government has set and see the kind of growth in heat pumps across the country that the market will need, we will need to quadruple. That's a 400% increase in the number of refrigeration mechanics working in the residential sector. We need to do that inside of 10 years. And I will tell you right now, that's an impossibility. We cannot train that number of, because it's a 4 or 5 year trade to become a licensed refrigeration mechanic. This is a really, really big challenge. And as I said earlier, the best control to ensure none of these gases leak into the atmosphere is to have properly trained, competent refrigeration mechanics and apprentices doing that work with the right training. So that is, in our view, by far the biggest challenge for overcoming the smooth transition to these gases in the context of proliferating heat pumps across the country. So those are my initial comments. Thanks. Oh, and I should just put the slide that's up there points to some training that HRAI has developed in partnership with a US company called ESCO. If anyone wants to write that down, that training is mostly aimed at technicians, but it does talk a little bit about the properties of these gases and how they need to be handled differently as a technician. So that's why it's on the screen. Okay, thanks.
Great, I think I'm next up. So I've been asked to speak briefly about the experience of the EU and what is going on in Europe concerning refrigerants and heat pumps, which I'm very happy to do, but to cram it all into 7 minutes is going to be a challenge, so bear with me. As some of you may know, the EU has just gone through quite a long revision of their existing regulation on F-gases. The EU has always been at the forefront on ambition on phasing down refrigerant gases, often starting a few years ahead of the international schedules. So the EU is often looked at as kind of an example of what to do and sometimes what not to do. So this new revision of the F-gas regulation is coming into force next week, March 11th. And it includes the world's first HFC phase out. So by 2050, there will be no more new HFCs allowed into the EU, which is extremely ambitious and the first of its kind. But when we talk about actually heat pumps in the regulation, I think one of the most important measures that has been introduced or strengthened are the product bans included within that regulation. The table here shows just a snapshot of some of those many new bans or kind of improved bans, as it were. And these are the main bans on heat pumps. And you'll see here that there are different GWP limits for which gases can be used in different kinds of equipment based on the type or the size of the equipment and the year that that ban comes into force. For smaller plug-in monoblock systems, you'll see that the GWP limit is 150 from 2027. But then crucially, and this is the newer part of the revision, the ban is extended to all F-gases, not just HFCs with a GWP limit, but this includes those F-gas alternatives, including HFOs. These will not be allowed in heat pumps from 2032. The same can be seen in the split systems. The smaller split systems are divided between air-to-water and air-to-air systems with that 150 GWP limit from 2027 and 2029 respectively. But again, that full F-gas ban comes into force for this equipment from 2035. And then for the larger systems, we start with a 750 GWP limit, which goes down to 150 in 2033. These are ambitious product bans, and industry had a lot to say about this, and there was a lot of debate back and forth, and a lot of analysis has been carried out by the European Commission, by analysts from the European Parliament, by NGOs such as ourselves, and by industry. And this is the result of tireless negotiations, but it shows what is feasible and possible if ambitious legislation is chosen. And then the other two quick measures that have been strengthened in the revision is that on training. Following on from what Martin was saying, training is so important if we want to move away from high GWP HFCs and to alternatives. Both HFOs and natural refrigerants require specialized training due to their flammability. So under the F-gas regulation, the mandatory training for technicians has now been extended not just to those handling HFCs, but to anyone handling HFCs and the alternatives, including natural refrigerants. And also just to note, the F-gas regulation is what dictates how HFCs are handled and dealt with in the EU. But there's another piece of policy that is coming down the pipeline as well at the moment, which will have an impact on heat pumps and cooling equipment. And that is the REACH regulation, which is how the EU deals with chemicals. And there is a new proposal that came out last year from a few member states, which was a PFAS restriction, essentially aiming to end the use of PFAS in the EU. This is important for heat pumps because almost all HFCs and almost all HFOs are considered PFAS under this regulation. So there is a possibility of neither of these types of gases, families of gases, being allowed under this regulation as well. Next slide, please. So quickly, I'll talk about natural refrigerants. They are not PFAS, so will not be dealt with under REACH. They are also not F-gases, so are not restricted under the F-gas regulation either. Natural refrigerants in heat pumps are mostly propane, as Heather said, but for larger installments and for industrial sized heat pumps, you'll also see a lot of ammonia and sometimes some CO2 in smaller systems. On the safety issue, it is a flammable refrigerant, but we have a new safety standard, an international safety standard that came into, was agreed upon last year or 2 years ago, which allows for a greater charge size in flammable refrigerants, up to 1 kilogram in residential heat pumps. And this will allow for greater efficiency and also greater uptake, kind of overcoming that hurdle of the flammability and the safety standards, which were restricting uptake of propane heat pumps. The graph there is a snapshot of the German heat pump market. It's quite small, so you probably can't make out what it says, but essentially it's the energy efficiency of the different heat pump models on the market in Germany last year. And the ones highlighted in green, those at the top of the energy efficiency, those are the propane units. So it really does show that propane is not only not regulated under these regulations, it is climate friendly, but also it is showing great energy efficiency. And then to the right is just a small image of kind of the market growth of heat pumps and how many companies are now offering propane heat pumps, where 5-10 years ago that would have been an empty image essentially. And then my final slide will kind of build on this idea. So like I said, the F-gas regulation revision doesn't actually come into force until next week, but the negotiations have been going on for almost 2 years. And so about 6 months ago, the writing was essentially on the wall and industry saw where the legislation was going to go and knew that these bans were going to come in place and that propane heat pumps were the smart choice, the future-proof choice to be making. And since then, we've seen a flurry of announcements as shown here in terms of new investments being made by heat pump manufacturers in Eastern Europe and also throughout Europe to build out the supply chain for propane heat pumps. And also some of the big name manufacturers launching propane models or extending their range of natural refrigerant models as well. So this just kind of very easily highlights the impact of clear signals from legislation and legislation also kind of paving the way by getting rid of those barriers of lack of training or restrictive standards as well. The EU model really shows that natural refrigerant heat pumps are technically feasible and cost effective and the kind of climate friendly future proof choice, as it were. Thank you.
Yeah, and so this is Mark Jerome. And so I wanted to talk a little bit about the U.S. Refrigerant landscape. So, as Martin pointed out, that the U.S. was late in signing the Kigali Agreement to the Montreal Protocol that came September 21st of 2022. And joined at that point in time 137 other countries. And then from there, we have federal pieces of legislation that dictate how we get this into the marketplace. And the AIM Act, which was part of the Consolidated Appropriations Act, directs the EPA, the Environmental Protection Agency, to phase down the consumption of HFCs. So this is a 85% over the next 15 years. And as a result, new HVAC equipment will need to have a GWP, or a global warming potential, of no greater than 700 by January 1st of 2025. Now, there are some stock sellout timeframes involved here. Not sure exactly how that'll play out. I've heard 1 year, I've heard up to 3 years. We'll have to see how that goes. Also, as part of the EPA, they put together these initiatives called SNAP 25 and SNAP 26, which put a list of appropriate refrigerants out there to be used in this phase down. And then also SNAP 26 went a little bit further and said this is the way that it needs to be structured per sector or per end use. And the GWP thresholds at that point. And so some different thresholds, will be some of the chillers may have a low GWP of 150, and we're seeing 150 and 700 and 750 a lot in these markets. And I think that's okay, because we're not going to have a refrigerant that's going to come in an HFC of 800 and go, gosh, we just barely missed the target. They're going to be below 700, or they're going to be those higher numbers, to 1200 and more. Then we flow down to the state level, and at the state level, we have different places like California, where they have the California Air Resource Board, which has set some thresholds of 750, where the EPA has it set at 700. So there's going to be some misalignments, but I don't think that it's going to hold anything up. Also, CARB did put in place where they said that room air conditioners and the packaged terminal air conditioners and heat pumps, like you might see in a hotel or a multifamily building, needed to have the low GWP refrigerants as of January 2023. And so we've done some checks. Looks like in California, room air conditioners are coming in and are HFC 32 refrigerant, which is great because that's lower than that threshold. So these things are already happening in the U.S. There is a group called the Climate Alliance. It's a group of 25 states that are going to try to align their A2L requirements. I think that's a big challenge because we're still seeing some states lag behind in allowing A2L refrigerants, whether it be in their building codes, or whether it be in their state, legislative laws and the way that they've put them together. So we're still getting there, but we're moving forward. Also with refrigerants, UL, our United Laboratories, which is a safety and product durability type of organization, and anything that comes into the U.S. as equipment, whether it be a vacuum cleaner or an HVAC piece of equipment, needs to be UL approved. ASHRAE is the Society of Engineers. Their 2022 versions of their documents, like 15 standard, and then 34, which is ASHRAE 34 is the standard that put the labeling, the A2L, and included that in, where before there was no A2L before 2019. So, and there's still a lot of states that are going through these legislative changes. So we're getting there. Next slide, please. And so then we're gonna take a look, and excuse me for a second while I move my notes here. And so state requirements will vary, but mainly we're looking at getting towards those final stages, which is going to introduce it into building codes, standards and some of the laws in order to allow that. Due to the legislation, there are some different thresholds. I don't think that's a barrier for us moving forward. Even though CARB has a threshold of 750 and EPA is 700, there's not going to be a refrigerant that's not going to fall within, outside of those ranges. So I don't think it's a real big barrier to have those differences. But or EPA's initiatives require that these refrigerants also update. The equipment needs to be updated that these refrigerants, these lightly flammable refrigerants, are going to be in. So they're going to need to have refrigerant sensors. They're going to have some control to trigger an action to dilute the refrigerant concentration so that less likely to have a leak or to have a fire in a equipment that's leaking. Most likely that's going to be done by some type of fan assist, but I'm not sure. I haven't seen any plans yet on that. But the EPA's rule is to phase down, not phase out. And so there's also some tricky little rules that come into play that is allowed, that you could replace an indoor coil on a split system or an outdoor unit, but with the high GWP refrigerant 410 or whatever's being used in that system, when you do a system both indoor and outdoor, you have to go to the low GWP refrigerant. So there's some little nuanced things that are happening too. But I do believe that due to the phase down and the limited stock that we're going to have of refrigerants, we're going to end up with it not being financially feasible for manufacturers or homeowners or building owners and operators to purchase R410 here in the next few years, because that price is going to continue to go up. And the same with all high GWP HFCs. So, and I think with that, I'm going to hand it back over to Roberto.
Thank you. Those are excellent presentations. Gives us a lot of great insight on what's going on, not just in the US and Canada, but also in Europe. So thank you to the four of you for that. So I will start with some questions here that we've got canned, but there's some really good ones in the chat that I'd like to get to right after this set here. But I'll start with you, Heather, with that original question about R&D, the kind of R&D development that the HVAC industry needs to accelerate adoption of GWP refrigerants and improve system efficiency.
Yeah, and I think that really comes down to having more and better refrigerant options available, and that's both for low global warming potential refrigerants for new equipment, but also for replacing refrigerants when there is a leak. So right now, if you have an equipment with R410A refrigerant in it and it leaks, you have to replace it with R410A because there aren't any other drop-in replacements that have the same properties and would use the same equipment. And that would be really nice if we could find refrigerants that could completely replace the high global warming potentials that are in existing equipment, especially when they leak. As Mark noted, they are going to become more and more expensive for replacements. And once a system has leaked, it has a higher probability of leaking again. So we just don't want to keep perpetuating that problem.
I just want to ask you, just before I move on to Martin here, I just wanted to ask you a question about one of your slides. You mentioned that there's a 2029 phase down, another step in the process. 2024 is one, I see 40% here, and then 2029 at 70%. Does that correspond with a GWP of 150 in 2029? Or is
Now
it just a
that-
global?
My understanding is that is phase down of the high global warming potential, the production and use of those high global warming potential refrigerants. I'm not sure about what the bar is in terms of what it qualifies as
The number.
global warming. Somebody else might be able to answer that.
Maybe Martin. Do you have an idea, Martin, whether 2029 is specified as like a 150 GWP?
I don't have that information in front of me. I was looking it up, but I won't be able to get it quickly enough for you, Roberto. Sorry.
That's fine. Okay, well, I'll hit you with another question then. Training. I really love the comment that you put in the chat there, Martin, about the fact that, a lot of the federal funding goes to incentive programs and some of it should be allocated to training. And I would argue also not just training, but recruitment of trades, of people into the trades. So training is important. You've obviously highlighted that over and over again. I see a chat or a comment from Jared in there about, lack of training and the kind of consequences that it could result in. I guess the question I have specifically is what kind of problems do you see or expect in the field as a result of insufficiently trained technicians? And can you also elaborate on the quality control that needs to be in place to catch that?
Well, that's a very good question, and it's been a challenge for our industry for decades. The challenge being that in the residential side of our industry, on the commercial side, just as a contrast, it's relatively more straightforward for enforcement bodies to check for the appropriate licenses that mechanics will have on a job site, because they're bigger jobs. If it's a big construction project, the Ministry of Labor can show up and say, okay, show me that you're working on a rooftop unit here, show me your gas license, show me your refrigeration mechanics license. And if they don't have it, they could be fined and kicked off the job, etc. In the residential world, it's virtually impossible for enforcement bodies to have that effect. They don't go around waiting to see who's in somebody's home working on a heat pump. It's unenforceable, practically unenforceable. So we've been told that for decades by enforcement bodies. So that creates a challenge. And as has already been hinted, most end users, whether homeowners or commercial building owners, they really don't know what they should be specifying when they take quotes from contractors. People don't know to ask the question, well, will this be installed by a licensed refrigeration mechanic? Can you confirm that you have competent people on staff? They don't even think to ask that question. So people don't know what they don't know. I would say that suggests that one part of the solution is to educate the marketplace to know that they should be only dealing with competent technicians. A second tool that we recommend at HRAI that we've not only recommended, but we've been part of programs that do this, is to make it a condition for any rebate program that the work has to be done by a pre-registered, proven contractor who actually can demonstrate that they have competent people on staff. Every time there's a program like Greener Homes, or you name any program that comes into existence, we see a growth in the number of contractors who are installing heat pumps, or who say they do. They come out of nowhere. And they didn't exist last week, and now they do. And if the rebate program goes away, so do they, right? Are they using competent, qualified people? We have no idea, but I suspect they are not, right? So we have recommended before that if the enforcement bodies can't do a decent job of it, why not let the incentive programs have an enforcement element by insisting that work must be done by competent people? There are ways to do that. It makes it for a more administratively difficult program to administer. And NRCan so far has chosen not to do that, against our advice. Some provincial groups, like in BC, there's the Home Performance Stakeholder Council, or the Home Performance Contractor Network, that has some element of this embedded in it. And it's a condition, if you want to rebate, it has to be done by someone who's in that network, and there's some due diligence on those contractors. So that's my recommendation, Roberto, of how to tackle it. But you're right, we need money to be spent on recruiting and retraining. And I don't want to exaggerate it. I'm not exaggerating. This is an enormous challenge, because the current availability of technicians is far below what the market needs.
Thanks, Martin. Very insightful. Sophie, I'll ask you the next question here. Thanks for that great update on what's going on in the EU. I think they're a bit of a guiding light as far as A3 refrigerants go, propane. What are some of the key lessons that other regions outside of the EU can learn from the European experience of phasing out high GWP refrigerants and promoting sustainable alternatives? What are the key takeaways?
Thanks. Yeah, like you said, the EU's kind of been the guiding light. They moved much faster. The first F-gas regulation was in 2014. So we've been doing this for a decade. We have a decade of experience in phasing down HFCs. And while some of it has been excellent, I think those 10 years have also exposed some of the pitfalls and the challenges that lessons can be taken from and avoided when other countries kind of embark on their phase downs or accelerate their phase down steps as well. One of the issues that was spoken about just now was price hikes in HFCs, these high GWP gases. We saw that in the EU massively. In 2018, the price of 410A, the price of 404A just skyrocketed. It went insane because there was a quota step down. So there was a reduction in supply, demand stayed the same for a few months or a year, and prices just went absolutely bonkers, which then led to a lot of illegal trade. One of the other things that EIA does a lot of work on is investigates the illegal trade of refrigerant gases. And this has been a big issue for the EU for the past 5 years. So this is another area where huge lessons can be learned, and a lot of the revision is tackling the enforcement at the borders, but also on equipment bans, on placing on the market issues, and also on kind of verification of who is doing what and putting what where. But I think in terms of kind of general lessons to be learnt, I think this issue about alternatives, that not alternatives are equal, is something that the EU is taking very seriously. Because we started earlier, we went from high GWP HFCs to slightly lower GWP, and then HFOs came into the mix. And the EU or the Commission rightly looked at the phase down and said, if we just do a pure phase down that's just looking at HFCs, it means that the growth in HFOs is going to go up massively. They didn't want that to kind of happen, given the environmental issues associated with a lot of HFOs, including their breakdown products, ecosystem damage, et cetera, and so the kind of to boost the natural refrigerant industry, which is doing very well in Europe and has really had a lot of funding, innovation, a lot more small players, big players getting involved. This precautionary principle approach to HFOs, I think, is something that other countries are paying attention to, especially developing countries are looking at this and looking to leapfrog directly from high GWP HFCs to the natural refrigerants and skipping out these unnecessary intermediary steps, which come potentially with an additional financial and technological burden of a double transition if you get it wrong the first time. So I'd say from our perspective, that is the #1 takeaway from what the EU has kind of learned over the last 10 years.
Yeah, and a lot has been learned. I would say that's the due diligence process that goes into these IEC standard evolutions and updates. I'd love to be able to have that expedite the next CSA B52 update so that we have all in place, that we can take all the learnings from Europe for A3 refrigerants and apply them to CSA B52 well ahead of 2029. Next question I've got here is for Mark. We're close to wrapping it up. So Mark, from your perspective, what are the main barriers preventing wider adoption of low GWP refrigerants in the US? And how could these barriers be overcome?
Yeah, and a couple things come to mind. And one is a positive thing, but it is a barrier. So in our energy efficiency programs, where we incentivize higher efficient heat pumps than a baseline piece of equipment there, and even with the electrification and transition from natural gas burning heating equipment, what one of the things that is being put in place is a cost for the refrigerant's potential to leak into the air over its lifetime. So if we go from a gas piece of equipment to a heat pump, there's a cost for future refrigerant leaks that's being included into these calculations that are making it so that it's not as cost effective as it could be with those regulations kind of pulled aside. Not a bad thing. It's good that they're accounting for that, but I think that's a challenge that's a hurdle. I think some of the other hurdles have been mentioned. You know, it's like no drop-in replacements for A2L refrigerants is a big challenge. We're not going to be able to go out there and put in some A2L refrigerant to replace 410, R22, or anything else because it's got to have those safety devices, you know, the refrigerant sensors and the controls to activate, some type of method to dilute the refrigerant concentrations if there is a leak that happens. I think those challenges are, and then equipment. Contractors have needing to buy equipment that is different. So, I think that definitely that can, slow down some of this transition too. So, and I know we're getting close to time. So,
Well, yeah, and just to reiterate a point that you made, that the fact that there's no drop in, I mean, there's a different kind of safety precautions that need to be put in place for A2L and A3s eventually.
Yep.
So yeah, the drop in nature kind of becomes a real challenge, and the fact that you need more safety precautions as you move up the 2L, 3 ladder, and that's something that makes the transition a little bit more challenging.
yep, definitely.
Absolutely. Okay, maybe we'll wrap it up here. We've got a few minutes left before I pass over to Matt. So I just wanted to say thank you, Heather, Martin, Sophie, and Mark, for your insight. I've got a killer lineup here of experts here, and we're privileged to hear from you and all the experience that you have. Matt, I'll pass it over to you.
Great, and thanks, Roberto, for moderating this. Hopefully everyone took a few new tidbits from this conversation. I know I did. It's very interesting. Just wanted to push one more time. If you are interested in becoming a partner of the Building Decarbonization Alliance, please do check out our website. There's an opportunity to sign up there. It is free. Just looking really interested in having you kind of join these conversations and participate in the discussion. And secondly, again, our forum is happening in Ottawa in April. If you enjoyed this discussion, we'll be having more time for further discussion as well. So looking forward to seeing you there. Thank you so much for joining today. I hope you have a great rest of the day.
Thanks, everyone.
Thank you all.